This is NASA's largest and heaviest rocket, the 16 million pound Space Launch System and Mobile Launcher. And while it looks like it's not moving, it's actually being transported to the launch pad. It's just moving incredibly slow, at just 1 mile an hour. To get it to the launch destination, NASA uses this, the $144 million NASA Crawler Transporter. Large enough to almost fit a professional baseball infield on top, it's the largest self-powered vehicle on the planet. And it's a key component to the Artemis program.
Fire.
NASA's most ambitious mission yet. Every long and complex journey into space starts with this slow 4-mile journey to the launch pad.
It's the first time that we will be carrying the full mobile launcher and the vehicle stack out to the launch pad. It's an integrated test to check out all the systems, so it's very important, and we're all working very diligently to make sure that it goes well.
The Crawler Transporter is so massive, it takes a crew of 25 to 30 trained engineers and technicians to operate it.
You have a driver and a backup driver, engineering responsibilities in the control room. You've got gel operator, which is our jacking, equalizing, and leveling system that keeps our load level. Then you've also got technicians in the engine room. You've got technicians in the pump room. You've got technicians roving around the catwalk, keeping an eye on all the hydraulic systems, as well as you've got people walking on the ground all around the crawler, keeping an eye out. They have a better vantage point than the driver, so they're in constant communication of how things look on the ground, where our trucks are pointed.
Drivers operate the crawler from one of 2 driver cabs located on opposite corners of the vehicle. Instead of reversing, the driver walks to the opposite cab to continue to steer the vehicle.
This button is what we use to acknowledge that our cab is in control. The lead engineer in the control room will actually go assign a cab control, and then the driver, whoever's in the cab, will acknowledge the command from this button. These 3 will let you choose your steering mode. So most of the time we're operating in great circle, which means the front cab is controlling all 4 trucks, and the crawler will actually turn in a big circle with the steering mode in the center.
It'd be one thing if the 4-mile journey was a straight line, but it's actually curved. And turning the crawler is one of the biggest challenges.
The crawler can only steer up to 6 degrees. So we've divided the steering wheel into 1-degree increments, and so we can have a visual representation of how much we're steering.
Driving on curves involves a lot more anticipation. You have to get your turn in early. You put your turn in, and then you have to wait a little bit before you actually see the trucks react.
The crew is responsible for transporting billions of dollars worth of research and development, so every crew member must have a full understanding of the crawler's systems and its 70,000 individual components.
So you see that right? See the wear here? It's the same on the outside. See, it's not wearing down here, but you get that wear there.
To become certified to drive, it depends person to person, but usually it's somewhere around 1.5 to 2 years.
While many different rockets have sat on the crawlers over the years, the crawlers themselves have remained the same.
The 2 crawler transporters we have in our fleet have transported every single launch vehicle from this vehicle assembly building out to pad complex 39A or B since 1965.
The Marion Power Shovel Company built the crawlers in the 1960s by adapting its mining equipment and used 2 locomotive engines to carry up to 12 million pounds.
And with the extensive maintenance done over all these decades, we've kept this thing running, in some cases as good as it was new.
In the past decade, the crew has adapted one crawler transporter to increase its carrying capacity for the SLS.
These are called our traction roller assemblies. This is what supports the entire weight of the crawler. These trucks will constantly spin all around this, and these will support everything, including we put the rocket on top.
When we started replacing these 88 roller bearings, we did them in 1 truck at a time, so that would be 22 at a time. Then we took it out for a test run, and that would be 6 months worth of work there.
In total, it took 5 years just to upgrade and test all 88 bearings.
Before the upgrade, they were originally designed to carry 12 million pounds. And now with all of our upgrades, we can carry at least 18 million pounds.
Inside the crawler, the vital systems that run the vehicle sit inside the engine room.
So behind me here is our Alco engines. They're 2,750 horsepower. These engines are original to the crawler. I mean, they've never been replaced. They're one of the few still remaining things from the original NASA program. And this is our Cummins AC generators. These provide AC power for all our onboard systems, including our motors for our pumps, our fans that are standing directly below here to actually introduce clean, cool air into the engine room for the techs that are in here.
Today, the crawler is making its way from the crawl yard to the vehicle assembly building, where it will pick up the SLS and mobile launcher for the first time.
If anything doesn't feel right, if anything doesn't look right, or something's not right, stop. Bring the crawler to a stop.
After a briefing, the crew inspects every inch of the crawler before they get the all clear to start the engine.
We check all the different pins, cotter pins, quarter stocks out that holds the track together. We check every single one of them on every single belt just to ensure that they are there, because we don't want to break a belt on the way.
With everything in working order, the journey to the VAB is underway. Engineers and technicians walking alongside the crawler, referred to as walkers, are responsible for flagging any potential issues to the rest of the crew.
I'm checking the gear case pressures. It has to maintain, a certain pressure in order to function properly, otherwise you'll get an overheat. You're doing an overall check of the whole crawler just to make sure that everything is hunky-dory so we can get to where we're going.
As the crawler nears the VAB, the driver begins to bring it to a stop.
We are slowing down our speed pot, bringing the crawler to what we call a normal stop by just dialing back, slowing down gradually, giving all of our systems an opportunity to adjust and just slowly come down.
It takes about 14 crew members to plug its power cable into an outlet for shore power.
We always like to keep our systems running like a computer in your house. You don't shut it off every time you use it, it just goes to sleep. So all of our electronics are that way, they go to sleep. And then we have certain types of heaters that keep our engines kind of lukewarm all the time so they're not starting cold. So that always needs to be powered.
These last steps ensure that the crawler is set up for its ultimate task, receiving the SLS and mobile launcher. This roll to the launch pad will test all the work the crawler team has put in over the past decade.
The crawler actually crawls or traverses underneath the vehicle and the mobile launcher. Once we're positioned correctly underneath these gel cylinders, we jack up, lift up the whole vehicle off the mounts.
With the rocket secured on top, the journey to the launch pad begins.
The ground's not always flat, so we have this jacking and equalizing and leveling system that we use to maintain level throughout the transport of the Artemis vehicle. We have an automated system that actually kind of keeps track of our parameters. When we're going up the slope itself, we have one end of the vehicle jacked all the way down, the other end is jacked all the way up, so we've got a range of about 5 feet.
Ahead of the crawler, a truck sprays about 30,000 gallons of water onto the rocky path, which the crawler pulverizes as it inches towards its destination.
The rocks that we roll on, as we crush them, it creates dust. These motors below us here suck in a lot of air to keep them cool while we're rolling, so that dust will get caught up in those filters and they'll clog them up. So by wetting all of the rock, that keeps the dust level down, and then it also changes the friction on the rocks, so it makes them easier for us to turn.
It ultimately takes 10 hours and 28 minutes for the crawler to reach its destination, where it finally lowers the SLS onto the launch pad. The SLS will remain at the pad for a 2-day wet dress rehearsal, where the team will run through the countdown and other procedures. No matter the mission, every long and complex journey into space starts with this slow 4-mile journey to the launch pad.
It's not a piece of flight hardware, it doesn't get all the fancy press that the launch vehicle does, but in the background, we're the most important piece of equipment.